Okay, we've made it to the last section. Thank you so much for sticking with us. I really hope you're excited to wrap things up with some web development. You know, we've just covered so much, and I sure hope you're feeling as proud and smart as I am at this point. We're going to start this section with this video, which will talk about APIs and comment about why they might be RESTful. In the next video, we'll get started with the Flask framework. We'll make a Hello World app, and finally we'll tie everything together and create a custom web application, which will combine the Flask framework and SQL to make an actual web app that we can interact with and saves data. Let's start by talking about APIs. APIs are helpful for interacting with the internet and services we use every day. Services like Twitter, Google Maps, and well, you name it. It's an agreement between our local machines, our local applications, and servers about how to reliably communicate with each other. This really helps us from reinventing the wheel. Can you imagine if we had to create Google Maps from scratch? So in this video, we will touch on what APIs are and what makes them RESTful. That we'll see not only in this video, but in the preceding videos. And then we'll provide a simple demo of connecting to an API within Python. You will probably hear RESTful API often. And honestly, it's not too much to be worried about at this point. What makes an API RESTful is pretty simple. It simply states that a client, say our application, should not need to know anything about the server's API, but rather that we can just trust that it will follow HTTP's expected commands. It's essentially agreement between all parties that they don't need to know details, they don't need to know what language you're using, they don't need to know what OS you're on. Everyone can just agree that we're going to communicate in these specific ways. And so these important commands that everyone at the game understands is get, where we simply want to get information from a service. We're not going to make any alterations or do anything with it. We just need to know stuff. Put and post are pretty similar commands. To appreciate the difference, we need to understand idempotence. Let's say that a customer enters their billing address into my records. If they want to update their address at some point, I would expect my application to update their address, not to add to a list of existing addresses. This is idempotent and how the put command behaves. Data put will entirely replace whatever exists at that memory address with a new resource, regardless of how many times the form is submitted. However, if they enter multiple sandwich orders, the form should save each item by appending it to the list, not overwriting it. This corresponds to the post command. And lastly, the delete command, which is pretty self-explanatory. We'll be seeing these commands often in the next few videos. So here, let's go into our example. I'm choosing to use the National Oceanic and Atmospheric Administration's API. It's very handy and it's public, and so it's pretty straightforward. If you go to this link here, you can give them an email address and they will email you a token. Now, because we're interacting with these data services, you'll often need some sort of authentication. This could be username and password, just like we've seen in the SQL videos. However, I chose a service that's going to use a token, which is a long string of seemingly random characters. If you want to find an API to play around with, there is a whole list of very handy APIs here. Okay, I have my token from the NOAA, and so let's go over in PyCharm to use it. Just like we did in our remote SQL example, let's define the important parts here. If I had a username and password, I would also put them here. But as I said, I'm using a token, which we can see here. This string was emailed directly to me. I was able to copy and paste it. We need to do a little bit of formatting so that it helps our get command. We need to do a little bit of formatting so our API can recognize that I am an authenticated person. And so to do this, I simply turn my token into a dictionary. I also let it know what kind of data I'm expecting. So the D type, or data type, in my case is data. You can go to the NOAA's API website to see what other types of data you can pull. Now we're going to use our requests library. Request is the API package I'm using here. So I go requests.get. Remember that keyword, get. I pass in the URL, which the API is going to be the same. You can copy and paste this, and then once you have that, you can start specifying which data you're interested in. So in my case, I'm choosing a data set that has an ID GHCND, as well as a location, which is a zip code. I'm also only going to be looking at the data for May 1st, 2010, which I specify with the start and end date. And then once the string is done, I pass in the data type and the header, which contains my tokens. I could print this by going req.text. In fact, let's go ahead and do that. We can see I get a long string. In fact, this should look a little bit familiar to you. So instead of going req.text, The request packages does allow me to call .json on it without importing JSON, to JSONify it, if you will. And then I did import JSONs just so I could dump this data into a JSON file so we can look at it a little bit easier. So if we come over to our projects pane, I can double click my JSON. Now, do you remember how to change this so it's human readable? One way is to go to Code, Reformat Code. There we go. That's looking pretty good. So you can see I get a lot of results here, but they should all be for May 1st, 2010. I'm guessing PRCP is precipitation, snow. I get their values. We should see that the station is consistent here. I don't know how these weather stations work, so I'm not sure what these other values are. So we can see that if I wanted to refine this further, I could simply pass in more data into my GET request.